talking about quadrilaterals for a little while, and at first we're going to be focusing on one special kind of quadrilateral, which is a parallelogram. Okay, which parallelograms are a special kind of quadrilateral, which if you don't know, quadrilaterals have four sides, so it's a figure with four sides. So, a parallelogram, let's talk about what that is. So, a parallelogram, it's a quadrilateral that contains two pairs of parallel sides. So, it's kind of in the name. It describes what it is within the name. So, a parallelogram has two pairs of parallel sides. Parallelogram. Okay, it has parallel sides. That's what makes something a parallelogram. Okay, so a parallelogram, we have two sets of parallel sides. So BC is parallel to AD because they have the same amount of arrows marked on each side. And AB is parallel to DC because it also has the same amount of arrows. DC and AB have one arrow while BC and AD have two arrows. So these two are parallel and these two are parallel. Nifty, right? Now let's talk about the symbol we use to denote parallelograms. So in geometry, mathematicians get really lazy and they don't like to write out the word parallelogram. So we have a symbol that means parallelogram. So if you see this nifty symbol here, it means parallelogram, which guess what, you guys? It's a small parallelogram. Holy hot dog, right? Okay, and the way that we name a parallelogram is by its four vertex points, which those are the little pointy parts on each end of the quadrilateral or parallelogram. So this is parallelogram A, B, C, D. And you have to kind of work your way around the figure. You can't jump around, like you can't say like A, C, D, B. Okay, so you have to work your way around the figure. It does not matter which vertex point you start at as long as you work your way around the figure. So this one, I could also call it parallelogram B, C, D, A. Or parallelogram CDAB, or parallelogram DABC. Okay, so you pick a point and you work your way around the figure and you put the little parallelogram symbol in front. So this means parallelogram because it has the symbol ABCD. Awesome, right? Now let's talk about different parts of the parallelogram because we have to know what certain parts are called so you know what I'm talking about when I address those parts. So the first thing that we're going to talk about are opposite sides of a parallelogram, which these are the sides that are across from each other in a parallelogram. Blah, sorry guys. So if you see here, I have a lovely parallelogram. So one pair of opposite sides are AB and DC. They are the two sides that are across from each other, or are on opposite sides of the parallelogram. So AB is right across from DC. So these are opposite sides, as well as AD and BC. So BC is right across from AB, if you can see. Pretty neat, right? I didn't mean to rhyme right there, but I'm pretty cool when I rhyme. Anyways, other parts of parallelograms. We have opposite angles, which guess what, you guys? They're the angles across from each other or diagonal from each other. So one pair of opposite angles are A and C. Okay, A is right across from C. And if you see, they are diagonally across from each other. Nifty, right? Okay, the other opposite angles are D and B. So D is right across from B, or they are diagonally across from each other. So they're not the ones like right side by side, they are diagonally across from each other when I say opposite angles. Another part, or other parts of the parallelogram, are consecutive angles, which those are the angles that share a side, and these are your same side interior angles. So, what letter does the same side interior angle make when we have parallel lines? You guys remembered. You're so good. It is the C or the U or the N. Since parallelograms have parallel lines, guess what, you guys? Those nifty angles created by a parallel or created by a transversal cutting through two parallel lines might pop up. So you need to be on the lookout for that. But since we have two sets of parallel lines, that means that we will have same side interior angles, which are sometimes referred to as consecutive angles. So angle A and B are a set of consecutive angles that make the C shape, bam, or in this case more of an N shape. Alright, we also have A and D, they make your more traditional C shape, bam. Alright, we also have angles D and C, they make like a upside down kind of sideways C, bam. And finally, we have C and B, which they make a backward C, like that. Cool, right? Okay, so if I refer to consecutive angles, or I might call them same side interior angles, okay, they are also going to be parts of your parallelogram. Now, parallelograms have special properties. Okay, so we're going to be going over the different parts of a parallelogram, and those parts will have some nifty properties, which will help us when we're solving for parallelogram values. Okay, so if a quadrilateral is a parallelogram, then one of the properties is your opposite sides of a parallelogram are congruent. Pretty cool, right? So your opposite sides, these two are going to be congruent, and these two are going to be congruent. So opposite sides of a parallelogram are congruent. Another property, opposite angles are also going to be congruent. So these two are congruent, and these two are congruent. So the angles across from each other diagonally are congruent, which is pretty awesome if you ask me. Our next property we're going to talk about, our same side interior angles are supplementary. So if I go back to those C angles we talked about earlier, so any of these angles, A and B, A and D, D and C, or C and B, they will be supplementary, which means they add up to be 180. So you need to be on the lookout for those. Okay, I'm going to fast forward back to there, sorry. So any of our same side, any of those C-shaped angles you see on the parallelogram, so be on the lookout for them, will be supplementary, which means they add to be 180. All right, and our final property of parallelograms is that your diagonals bisect each other. So let's think about it. What does bisect mean again? Holy hot dog, you guys are so smart. Bisecting does mean something slices something in half. Okay, so the diagonals are going to slice each other in half. Bam, bam. Okay, so they slice each other in half and create two congruent segments. So these two are congruent, and these two are congruent, which means where the two diagonals cross, this means that this has to be the midpoint because it creates two congruent segments on this side and two congruent segments on this side, which is pretty cool. Now, be careful though. That does not mean that all four of these pieces of the diagonal are congruent. Only these two are congruent and these two. Don't be assuming things in geometry. Bad things happen to people that assume things in geometry, so watch yourself. Okay, so these two are congruent and they are not necessarily the same thing as these two, so be careful. All right, so using all these nifty properties of parallelograms, we're going to be solving for all the variables and the sides and angles containing the variables. So we have to think back to our 5 properties as we solve these. So go ahead and pause this video and watch example 1, example 2, and example 3. And that's it for this Prezi. I had so much fun, you guys. Thanks.